Here we have AP calculus AB problem. Okay, let's go to the question. If f of x equals to square root of x square negative 2 over x square positive 2, then f prime of 2 equals to. Okay, here we have the function f of x and we have to evaluate the first derivative, that is f prime of x at x equals to 2. Okay, now to get the value of this f prime of 2, first we need f prime of x, that is the first derivative of the given function f of x. Okay, if I want to get the first derivative of the given function f of x, what I have to do is first I have to write the square root as exponent 1 over 2. That is f of x equals to x square negative 2 over x square positive 2 raised to the power of 1 over 2. That is I have written the square root as exponent. Okay, when I find the first derivative of this f of x, it will become f prime of x. On the right side, when I find the derivative, first I have to do derivative for the exponent 1 of using the power rule of derivative. That is I have to bring this exponent in front of this stuff and I have to subtract 1 from this exponent. So this is derivative only for this exponent 1 of. By chain rule, I have to further derivative for this stuff x square negative 2 over x square positive 2. But when I try to get derivative for this one, I have to use a quotient rule, because here in this stuff we find variable in both numerator and denominator. But it seems to be a little complicated process to get derivative of f of x. So how do we have to make this easier? So we can do logarithmic derivative. So what is the advantage of using logarithm derivative? So to do logarithm derivative, what we have to do is we have to take logarithm on both sides of the given function, and then using the properties of logarithm, I will be able to split up this complete stuff into parts. When we split up this one into parts, the process of finding derivative will be easier. Okay, now to do logarithm derivative, before we take logarithm on both sides of the given function, let's replace this f of x by y for our convenience. Okay, now let me take a natural logarithm on both sides. That is ln y equals to ln of x square negative 2 over x square positive 2 raised to the power of 1 over 2. So why do I take natural logarithm on both sides? Because the derivative will work only with natural logarithm. Okay, now what we can do is we can write this ln y as it is. Here we can use the properties of logarithm. So first let me use the power rule of logarithm. That is, if the argument of a logarithm is a power, then the exponent we have with the argument can be moved in front of the logarithm and it has to be multiplied by the logarithm. Then I'm getting 1 over 2 times ln of x square negative 2 over x square positive 2. Okay, now we have ln y equals to 1 over 2. Now again we can use the properties of logarithm. That is, we can use the quotient rule of logarithm. That is the argument of logarithm. If two quantities are in division, what we can do is we can take logarithm for the numerator and denominator, and then we have to subtract the result. That is natural logarithm of x square negative 2 negative natural logarithm of x square positive 2. Okay, now that's all the properties we can use, properties of logarithm we can use in this one. So now what we can do is we can find derivative on both sides with respect to x. Let me write it over here, differentiate, let me write it, differentiate with respect to x on both sides. Here I am going to find derivative on both sides of this equation with respect to x, because f of x, it's a function of x, so f prime of x means it's a derivative with respect to x. Okay, now let's do derivative on the left side. That is, let's find derivative of this ln y with respect to x. When I find derivative of natural logarithm, what I have to do is I have to write 1 in numerator, and whatever argument we have over here, it has to be written in denominator. Okay, now we have completed derivative only for the natural logarithm. By chain rule, we have to do derivative for the argument y with respect to x. So then it can be written as dy over dx, or it can also be written as just y prime. Okay, on the right side, so this is a part which contains variable and it is multiplied by the constant 1 over 2. When I find derivative, if there is a constant multiplied by the variable, what we have to do is we have to keep the constant as it is and we have to find derivative of the variable alone. Okay, now let's do derivative for this natural logarithm. Then I have to take 1 in numerator, and whatever argument we have over here, it has to be written in denominator, that is x square and negative 2. Okay, I have completed derivative only for the natural logarithm, as I said for this ln y. Now we have to do derivative by chain rule. We have to do derivative for this argument x square negative 2. When I do derivative for this argument x square negative 2 with respect to x, I'm getting just 2x, because the derivative of x square with respect to x is 2x. The derivative of this constant will become 0. Negative. When I do derivative for this natural logarithm, I have to take 1 in numerator, and the argument of the logarithm has to be taken in denominator, that is x square positive 2. Now we have to do by chain rule, we have to do further derivative for this argument x square positive 2 with respect to x, and I'm getting 2x. Okay, let me continue. Then we get 1 over y times y prime. So when I multiply this 1 over y and y prime, I have to multiply this numerator 1 and y prime. Then I'm getting y prime over y equals to 1 over 2 times Now we can multiply this 1 and 2x, and I'm getting 2x over x square and negative 2 so 1 times 2x is 2x over x square positive 2. Okay, let me continue on the next page. We have y prime over y equals to 1 over 2 times 2x over x square negative 2 2x over x square positive 2. Okay, now to solve for y prime, I have to get rid of this y in denominator. For that, we have to multiply both sides of this equation by y. Let me do it. So then this y will cancel out. We get y prime on the left side. Then on the right side, we have y times 1 over 2 times 2x over x square negative 2 negative 2x over x square positive 2. Okay, actually instead of y prime, what we can write is we can write f prime of x, because we have taken y for this f of x. Since we have taken y for f of x, when we have y prime, we can write f prime of x. So now what we can do is on the right side we have y over here. We know that y equals to x square negative over x square positive raised to the power of 1 half. Actually, this is the stuff we have written the square root as an exponent 1 half. So for y, what we can write is we can write this stuff, that is square root of x square negative over x square positive. Let me write over here. We can replace this y by square root of x square negative 2 over x square positive 2 times 1 over 2 times 2x over x square negative 2 negative 2x over x square positive 2. Okay, now we got f prime of x, but our aim is to find f prime of 2. So now what we have to do is we have to plug in x equals to 2. When I plug in x equals to 2 over here, on the right side also at everywhere I have to plug in 2 for x, then it will have over here 2 square negative 2 over 2 square positive 2 times 1 over 2 times 2 times 2 over 2 square negative 2. Let me finish writing. Negative 2 times 2 over 2 square positive 2. Okay, let me continue over here. So we have f prime of 2 equals to square root of, so this 2 square is 4 negative 2 is 2. We have 2 in numerator, and in the denominator 2 square is 4 positive 2 is 6 times 1 over 2. Here 2 times 2 is 4 divided by 2 square is 4 negative 2 is 2 negative. So here 2 times 2 is 4 divided by, and 2 square is 4 positive 2 is 6. Let me write it. Okay, then we get f prime of 2 equals to, so here 2 goes into 2, 1 times 2 goes into 6, 3, then we get square root of 1 over 3 times 1 over 2. So 4 divided by 2 is just 2 negative. So here 2 goes into 4, 2 times 2 goes into 6, 3 times, you get 2 over 3. F prime of 2 equals to, we have square root of 1 over 3 here. Since we have square root for the fraction 1 over 3, we can distribute the square root for numerator and denominator. When I distribute the square root for numerator, I am getting square root of 1. Square root of 1 is 1 divided by, and we have square root of 3 in denominator times 1 over 2. Now, what we can do is here, we have to do subtraction between the integer 2 and the fraction 2 over 3. Whenever I want to do addition or subtraction between an integer and a fraction, we have to multiply the integer by the denominator of the fraction. Once I'm done with this multiplication, I can take this 3 as a common denominator. So 3 times 2 is 6 negative 2. Since I have multiplied this 2 by 3, now I can take this 3 as a common denominator. Let me continue. F prime of 2 equals to 1 over square root of 3 times 1 over 2 times. So 6 negative 2 is 4. That is, we get 4 over 3. So here 2 goes into 2 1 times and 2 goes into 4 2 times. I am getting f prime of 2 equals to 1 times 1 is 1, 1 times 2 is 2, 2 divided by square root of 3 times is 3 square root of 3. Okay, here in denominator we have an irrational number square root of 3. Usually when we have irrational number in denominator, we will rationalize it. For that, what we have to do is we have to multiply both numerator and denominator by square root of 3. So when I multiply them, I am getting 2 times square root of 3 divided by, so here we can write this 3 as it is. When I multiply the square root of 3 and square root of 3, I am getting 3. So finally, I am getting 2 times square root of 3 over 3 times 3 is 9. Okay, now I got the value of f prime of 2, that is 2 times square root of 3 over 9. Okay, now let's go to the question. We find 2 times square root of 3 over 9 in answer choice A. The correct answer choice for this question is A.